sorry. Still there?
Yeah.
You're good, man. We can let you drive in safety.
Okay. All right, yeah, guys. Hey, I appreciate it. Sorry about that.
Nope, you're good.
Hey, before I drop you guys, is there anything that did we get a response back yet? Does anybody know if we got a response back on that Levi's version?
Nope. I resubmitted it Saturday night with the changes, and I still haven't heard anything back. So, yeah, that's where we're at right now. As soon as I hear anything, I'll let you guys know. I'm hoping it's gonna be sooner rather than later, so we can get started on the next portion. The one thing he did say is that we should not use social media, just to use the IRB stuff, that the email addresses they give us, which is fine.
Okay.
We'll just do that, and then the other changes I made, and hopefully he'll come back and let us know we're fine.
Okay.
All right,
hey Garrett, real quick, just so you guys know, I don't know if you guys had a chance to watch the video he put out today, but if you go into the course under content, the very last under resources, there's a thing called statistics, methods, table, and flowchart. If you use that and fill it out, you can use that on the test, on the exam, and it does not count towards your 1 page of notes. And it gives you the breakdown of like categorical, quantitative, and then just kind of going down through the different options to determine what kind of test it is, if you want to use it.
Oh, that's dope.
Yeah, it's pretty nice.
I just watched this video and I'm filling mine out now, and it's really helpful just to make sure you got the right test.
Yeah, because my pages have been pretty crowded in the last few chapters. Well, I think the first one wasn't so bad, but the last two that we've taken have been pretty bunched with just notes and equations and formulas and stuff. So that's good to know.
Yeah.
All right.
Well, drive safe, Garrett.
I'll catch up on this with you guys on Wednesday. Sorry about that.
All right. Later.
All right. See you, Garrett.
All right.
We're on lesson 20 group quiz, right?
Yep.
All right. Started.
Let's try it.
All right. Question 2, which is question 1.
This is a small business. So this is the one that, hold on. Small business. No, hold on. They're out of order. No, that's the same one. So this is the one that I think was a chi test.
Yeah, it's the same I got.
Number 2. So I'm thinking I did paired t-test, but I might be wrong on this one.
So I did a test of 2 proportions. And the reason I did that is that they are technically categorized.
Right.
And then they don't depend on, like, it's 2 different proportions. So it's the proportions of people less than 40 and the proportions of people greater than 40.
Gotcha.
That's kind of my thinking there.
No, I could definitely see that. Okay, 4. Wait, nope. Did I skip one? Nope, but that is 4. Yeah.
No, you're right. It's confusing.
Survey was conducted by a group of state lotteries, a random sample of 248 people.
For this one, I put 1 proportion.
1 proportion?
Yeah, because again, they're breaking them up into different categories, and then they're looking at just the one category of the heavy players.
I could see that. Okay, yeah. 1 portion. Wait. Oh, okay. Tested 1 portion. There we go. Okay. And then 5. A student project compared the effectiveness of 2 different combination locks. Okay, yeah. This one I remember stumping me. So we're talking about which one's easier. So this would be this would be categorical, right?
Well, so the way that I looked at it is that they're looking at the time that it took them, which would be quantitative.
Okay.
And then from there, I looked at are the samples dependent or independent? And I figured they were dependent because whichever student opens lock 1 is also going to open lock 2. Like it's because it says that's the way that I looked at it. I don't know if that's right or not, but that's how I kind of looked at it because
No, I can
they're not picking 25 students to do 1 and 25 students to do 2. They're picking 25 students to do both of them.
Yeah, they're giving their own. This one takes less time than this one.
Right. So I did paired samples t-test is what I was thinking.
Yeah, I would agree with that. Oh shoot, scrolled too far.
Question 6. I think I got the same one. Again, because it's quantitative, it's looking at the numbers, the value of the property. It's dependent samples because they're looking at the same 6 properties for both of them. And then obviously from there we get a paired t-test, but I'm not sure. That was one I wasn't sure on.
Yeah, let me reread it real quick. Sorry.
Yeah, you're good.
Yeah, I would say same. Yeah, the paired sample t-test.
Okay.
Oh wait. Paired sample t confidence interval. Is that what you did?
Yeah.
Okay. Okay. In the Wall Street Journal, an article on satisfaction with career paths and percentages of psychology majors reported that they were satisfied. So this is categorical. The career paths. Decided.
So for this one, I did 2 proportions because they're looking at accounting majors versus psychology majors and the percentage of each that are satisfied or very satisfied.
Yeah, that sounds. I agree with that one.
Question 8 is about the double stuffed Oreos. I was thinking independent sample T confidence interval. And the reason I picked that is because, again, it's quantitative. They're measuring the stuffing. There's no known. Wait, hold on. What did I put? Hold on. Sorry, I lost my train of thought.
It's okay. It's okay.
So this one. So actually, with this one, would it be? I'm assuming it would just be what, 1 sample, right? Because they're only measuring just Oreos.
They're measuring the is it the amount of filling in each one? So that would be quantitative,
right? And then it goes down to 1 sample, 2 samples, 3 samples. It would only be 1 sample because they're just doing double stuffed Oreos. They're not doing.
Yeah. So where's 1 sample t-test? Wait, sigma.
Well, in this case, it should be known, right? Because they're saying it should be double.
Yeah.
So we have something to base it off of.
So yeah, the Z test.
So 1 sample Z confidence interval.
Yeah.
Okay.
I don't remember that one. I wonder if I accidentally skipped over that one. Okay, which of the following best defines the notion of significant levels of hypothesis tests? Probability of observing a sample statistic more extreme than the one actually obtained, assuming the null hypothesis is true. The probability of a type 1 error, the probability of rejecting HO, whether it's true or not, the probability of the type 2 error. I'm going with A on that one, right?
That's what I got. It was A.
Yeah. Okay, which of the following best defines the notion of a p-value of a hypothesis test? The probability of type 1 error, the probability of observing samples.
This one I thought it was type 1 because isn't the p-value the lower the p-value, the
less likely you are to create an error, right?
Right.
Yeah, I think that's right. Yeah, I really need to find my assignment. Yeah, I think you're right. I think it is A on that one.
Okay.
Okay, suppose you create a 95% confidence interval for a mean, and you get 10 and 20. You've been told to report this by saying something like, we are 95% confident that the true mean is between 10 and 20. Exactly what does this mean? Means.
This one always confuses me for some reason.
Yeah. So I think it's B. 95% of all 95% confidence intervals actually contain the true mean.
Okay.
Just because the few times I remember reading it, it always had the percentage twice, or maybe I'm fabricating that. Hold on, let me look up some of the other. We are percent confident that the true mean lie between nova and... Okay. Yeah, I don't know. What did you have?
That's what I had put, but I wasn't, like I said, that is not my
Expertise.
right. Like that's one that I always seem to get wrong.
Yeah, I think it is that one. I think it is B. Okay. You take a simple random sample of 100 adults from a town in western United States to determine the proportion of those in town who invest in stock market. Assume the unknown population portion of percentage of people in town who invest in stock market equals P, or 30%. What is the mean of the distribution of the sample proportion?
This is number 11, right?
Yeah, 12. Did I skip 11?
No,
11
you're
was
good.
Yeah, this is.
Well, yeah, no, I'm talking about like on the review.
Oh,
Yeah.
should be.
Yeah. So for this one, I wasn't sure if it was 30 or 0.3.
Yeah. It doesn't help that both of those are answers on this sample proportion.
So the reason I would say 30 is that because it's the 0.3 is the percentage, which is 30%, which is 30 out of 100, which would be 30.
I can see that.
That's how I was leaning towards 30.
Yeah, I'll go with that. That's yeah. I'm gonna make a note just in case. Okay. And 13, what is the standard deviation of the distribution of the sample proportion?
So I didn't get this one or the next one. I wasn't super sure how to do it.
Yeah, I know I did it, but like I said, I can't find my assignment. Let me see. Let's see. So we have N is 100. And then our P equals 0.3. Jeez, yeah,
So this is the one where it's the standard deviation of the p with the little line over it is equal to the square root of p times 1 minus p divided by n.
maybe. I'm trying to find my formulas.
Well, I have so many formulas now. I got to go back and try and figure them all out.
Yeah, I need to compile them.
Okay, so our value of p would be 0.3, right?
No.
And then,
Which did you find the formula?
yeah, I'm pretty sure it's that one that I said. The mean would be what, 30, 100. Oh, that didn't work.
This is from chapter 17 to 19, right?
Yeah, it's on chapter 17 that I found the confidence or the standard deviation formula.
Where p hat, p is equal to p hat times p hat, which is equal to x over n.
In that case, so the mean would be 0.30.
Yeah.
So, and then n would be 100. So then what I get for the standard deviation is 0.0458, so 0.046.
0.046, that's what you're saying?
Yeah.
Which is one of the options. Sorry, what was the formula that you were using? It was p.
So it's hold on. So it's p hat times 1 minus p hat divided by p, and that's in lesson 16, 3.2.2, where it says mean and standard deviation.
Oh, okay.
Yeah, so I got 0.046.
Let me punch it in real quick. Sorry.
Yeah, you're good.
Okay. What was the formula one more time? Sorry.
So it's p hat is equal to the square root. Well, here, let me just do this. I'm gonna just share my screen.
Okay.
So I can just show it to you. It's gonna be this one right here.
Oh, okay. Okay, I did this way wrong. No, I did that. So I'm getting like 0.836. Try that one more time.
So what? Okay, so here's the question. Let me stop sharing. What did you use for your mean? Because I think our mean is wrong. I think our mean is supposed to be 0.3.
Okay, yeah, that's what I did use. 0.3.
Yeah, so it should be. So the formula you should use, or at least that I'm using, is the square root of 0.3 times 1 minus 0.3, and then divided by divided by 100.
Okay, now I'm getting it. Sorry, I divided it by 0.3 as well.
Okay.
0.0458.
Yeah, so 0.046.
Yeah. Okay.
All right. And then what is the probability that your random sample of 100 adults will have a sample proportion less than 0.25? So let's see. Where's that probability applet?
So that's just p hat minus p divided by that last formula we used. So it's the probability that your random sample of 100 adults will have a sample portion less than 0.25.
Yeah.
So probability calculation, that's in lesson 16 at the very bottom.
Oh, okay. The value minus the mean divided by the standard deviation.
Yeah.
So the value is going to be what, 0.25, or is it going to be?
Oh, so that's going to be a p hat, so 0.0456 or 046.
Well, no, because that's the standard deviation.
But isn't that p hat?
Well, p hat would be the value they give us.
Okay, so if you look at, are you at the very bottom, the summary?
Yeah. Yeah.
So it shows p hat minus p divided by the standard deviation.
Right. So,
which would still be p hat.
So p hat would be the value they give us.
Right.
So it would be equals to 0.25 minus 0.3.
Right.
And then divide the whole thing by the standard deviation. And then that's going to give us negative 1.09. Then you take that and plug that into the normal probability applet for the z-score, and you get negative 1.091. And then you just shade the bottom half because it's less than that, and you get 0.1376.
Okay.
So 0.13. So it'd be 0.138 technically.
Ugh, I hit something wrong. Okay, let's see. Okay, let's do. Okay. Oh, I think the problem is it's coming out negative.
Well, it should be negative.
Yeah. Excel's not liking it for some reason.
Oh, okay.
Times by. Okay. Okay, what did you say you got?
So I got 0.138.
Wow, I'm way off on this. Okay. Because I'm getting negative 1.09 something.
That's right. No, that's right. So then take that and plug it into the probability applet.
Right.
And then you just shade to the left of the z-score, because that's your z-score.
Yeah. Yeah, that makes, okay. Okay, and then you're getting 0.138.
Yeah. Well, 0.1376, which rounds up to
Yeah.
0.138. Cool.
Yeah. Okay.
All right. Question 15. This corresponds to 14. What is the margin of error? So in this case, the way that they asked it in the quiz was the interval. So the interval that I got was negative 0.003 and then 0.029. Is that what you got?
I don't remember.
Okay.
Okay, let's, okay.
So I just plugged it into the two sample z test for proportions.
Yeah. Okay, so let me plug this in real quick. So we have 214, 2142 subjects. So that's my N.
Well, no, so your N is going to be, because that's the total. So N1, you're going to want to use that 1563 for just those in the experimental group.
Right.
And then N2 is going to be the 579, which is those who were in the control group.
Of the experimental group, 61 experienced dizziness. So
yeah, right.
Shoot. Hold on. You said you used the two sample t-test?
Yeah. Oh, two sample z-test for proportions.
Oh, okay. I'm on the wrong form. Right. Okay. Right. Okay. So we have 1, 3. Okay. It's 95% confidence interval. Okay. Margin of error. So this is 0.031. Is that what you got?
For
number 15, the margin of error?
No, so the margin of error is going to be, what'd you get for your confidence interval?
-0.003, negative 0.003 and 0.029.
Yeah, so remember the margin of error is going to be the upper bound minus the lower bound divided by 2.
Okay, so is this the 0.016?
Yep.
Okay, I labeled these wrong then. I probably got it wrong in the on mine anyway. Then the lower bound is the negative
0.003. Yep.
Upper bound 0.029.
Yep. Next one.
Perform the hypothesis test to see if the proportions of the experimental group subject who experienced dizziness is different than the proportion of the control group subject who do. Use the level of significance 0.05. What are the proportion, null, and alternative hypothesis? So this is the one where we always assume P1 is equal to P2, right?
Right. That's always going to be your null. And then in this case, it just says to see if they're different, so it would just be not equals.
Yeah.
So A.
Yeah.
Value of your test statistic, I got 1.458.
Yep, that's what I got.
You got 0.145.
Say that again.
0.145.
Oh, yeah. Sorry. I thought you were saying the same thing, but all right, never mind.
Yeah.
I didn't realize you moved on to the next question, and they're the same first numbers.
Oh, yeah.
Yeah, I got that too.
Okay.
Is there sufficient evidence to conclude that the true portion of the people who experience dizziness while taking is different than portion? So no, we failed to reject.
Yeah, so it'd be the last one, right? So F says no, I failed to reject the null hypothesis.
Oh, yeah, there is. Sorry. I was trying to figure out what the difference between, there's one that says, yes, I failed to reject.
Nice.
But yeah, you're right. It's no, I failed to, okay. Yep. Moving on. Okay. This next one's a chi test, right?
Yep. So this corresponds to number 19.
This one does?
Yeah. 22 in the group meeting quiz corresponds to number 19 in the review.
Okay.
So, because what they did is they made that margin of error question.
Right, multiples.
Yeah, right, multiple steps. So I got 6.580.
I'm punching them in right now.
Okay.
Okay. So 6.579. Wait, what did you get?
6.580. What did you get?
6.579. So it's the same. 6.
So I got the exact same. Yeah, so that's what I got. But then in the answers, it only says 6.580. So I just assumed they rounded up.
That makes sense.
The p-value, I got 0.087.
Hold on, I'm punching that in 6.58. Put 0. Okay, sorry, p-value 0.086.
Yeah, but again, in the answers it says 0.087.
Yeah, because you round up.
Yeah.
Okay.
24, it says, should you reject or not? I put no because where's it at? The p-value is greater than 0.05.
So A, yeah.
No. I put no.
Oh, no, the p-value is greater than... Oh, man, that no and yes is going to throw me off.
Then it says, what do you conclude based on your results? And I put, we have insufficient evidence to say that it's, wait, hold on.
Yeah, what was the theory again? Okay, so it's the second to last one. So C?
The one that says insufficient evidence to say that being a morning or evening person is independent of age?
Yeah, because the alternative hypothesis uses the word not.
Okay.
The hypothesis...
is just independent?
Yeah.
Okay. 23, 26 in the quiz, which is 23 on the thing. I got 0.190 and then 0.310.
Hold on. This is a 2 portion, right? No, hold on. This is a 1 portion.
Right, 1 portion.
All right, so you got 0.145.
No, I got 0.190.
For your lower bounds. Okay, what did I do wrong? Hold on.
Yeah, so for my X, I got 50. For
Wait,
my N, I got, because it says, where's it at? It says 50 of these outperform the Dow Jones national average, or whatever.
Yeah, okay. I put 40 because a recent book noted that 20% of all investment managers outperformed. Yeah, you're right. Okay. So 0.190.
Yep. Yep. And then 0.310 for the upper bound.
Yeah.
Question 28 is the one that asks about sample size. That's that formula. That's the formula that says
P is
Z divided by 2 times M to the square root.
Hold on. I'm trying to find that one. I know I wrote that one down.
It's going to be lesson 17 under section 3. So I shared my screen again. It's right here.
I've got it right here. Yeah, M is equal to Z star. Okay. Okay. Suppose you're going to say what sample size would need to be constructed of 2%. So this is the this would be the N is equal to Z star over M squared P star. Okay.
No, this is going to be, sorry. What did you say again?
Z star over M squared times P star times 1 minus P star.
No, this is going to be just below that, where it says N is equal to Z star divided by 2M to the square root, because we don't have a prior estimate for P. And so this is going to be, it says use the following formula to compute our sample size needed to achieve that.
Gotcha.
And then the Z is going to be that 1.96 for the confidence interval.
Oh, that's what I'm getting wrong. Okay, yeah. I need to remember to do that. Okay, over 2M squared. Wait, so what answer did you get?
I got 2401.
Okay, let me see what I'm getting here.
And then M is going to be 0.02.
Okay, let's see. 1.2. 2401. Is that what you said you got?
Yeah.
Yeah, okay.
So then 29, it says, which of the following pairs of, so it says, suppose you wish to see there's evidence that graduates of one of the top 10 business schools performs better than others. Conduct a hypothesis test using a level of significance of 0.05. Which of the following pairs of hypothesis is the most appropriate? I put E, where the null is going to be their equal, and then the alternative is going to be that P is greater than 0.2. Because you want to see if they're higher or if they're better.
Yeah, I agree with that one.
Question 30, it says, which requirements must be met to ensure that P hat is normally distributed? I put A, that NP greater than whatever.
Equal to 10.
The value of my test statistic, I got 1.768.
Wait, how did you get that?
The one sample z-test for a proportion. That same one we just used for the confidence interval.
Yeah.
So the confidence level is going to be 0.95. Null hypothesis is 0.20. Type of test greater than, and then it produces the test statistic or the z value of 1.768.
Okay.
And then the p-value, I got 0.039.
.039. Okay, I'm. Hold on a second. Sorry.
You're good.
So what did you get for X on that?
For x,
Am I not doing it?
x. So x should be that 50 still.
Okay.
The n should be the 200. The confidence interval is going to be 0.95. The null hypothesis is 0.2. And then the type of test is going to be greater than.
Right. Oh, right. Okay, I know what I'm doing wrong. Okay, hold on. All right, real quick. What did you get for N again?
For n, I got 200. I believe. Let me double check. I walked away for a second.
I'm getting this wrong. Hold on. What am I doing wrong here? $5,200.
You're under one sample z-test for a proportion, right?
Yeah.
Okay.
Okay, so I've got 50 as X, 200 as N, 95% confidence. No
Do you have 95 in there or 0.95?
0.95.
Okay. I actually did that last time. I was like, oh, 95. Okay. And then I was way off.
Yeah, what am I getting wrong here? Hold on.
The null should be 0.20.
Oh, you know, that's what it is. 0.02, or you mean?
0.2.
Okay, yeah. Shouldn't it be 0.02 though?
Yeah, no, because they give us the.
No, they gave it to us 0.2 right there. Okay, I had that one wrong. Okay, yeah. So 1.768. Yep, and then the p-value is 0.0771. So 0.077. Is that what you're getting?
For your p-value?
Yeah.
Do you change your type of test to greater than? Because you want to see if it's greater?
Yeah. Oh, I clicked on it. Didn't change. Yeah. 0.0385. So 0.039.
Yep.
Okay. And then 33. Yes, there is enough to reject the null hypothesis.
Yep. So A.
Okay. Computer software is commonly used to translate text from one language. Oh, we've had this one before in previous exams.
So this one I wasn't sure about. Like, I wasn't sure which test to use.
So I'm going to pull up that file they sent us. Take a look at it. Okay, so it's one group of data.
Right.
So I'm thinking it might just be a one sample t-test.
So that's what I did. So I put that in there. but then the t-value I got was negative 9,373.
Huh.
Actually, hold on.
I'm getting negative 3,683. Let's see.
Okay, so you got to change the null hypothesis to 0.295, and that helps out a lot.
Okay, I'm getting like negative 2.803.
Yep. So the question is, the type of test, is it going to be less than, equal to, or greater than?
Let's see if that changes anything. Sometimes it doesn't change anything. That does not change anything for the well, actually lower
The p-value.
does change the p-value. But the lower bound, it doesn't change. Hold on, let me read through this again.
So it's going to be not equal to. If you read the last sentence of the second paragraph, it says he wants to use this data to see if his mean score differs from the mean score of another translation software. So just not equal to. So the lower bound is 0.282. Is that what you're getting?
Yep.
Upper bound 0.293.
Yep.
Degrees of freedom is going to be 99.
Yeah.
A statistic, negative 2.803.
Hold on. Wait, test statistic. Oh yeah, negative 2.803.
And then the p-value is 0.006.
Yeah.
So based on this, we have sufficient evidence to say that the true mean is different than 0.295. Because 0.006 is less than 0.05.
Yes.
All right.
All right.
So now we're going to do the, this is another one we used before.
Yeah. Okay, so this is, okay.
This is a paired sample t-test, if I remember correctly.
I think you're right.
Yeah, because it gives the heights in the morning versus the AM.
Okay, so they are.
So let's see, the data is recorded. Define the differences as AM height minus PM height. So AM height is going to be our
value 1.
Value 1, yep.
Okay, and we have a 95% confidence.
Yep, so 0.95. The null hypothesis is that they are the same, so there's no whatever. And it's going to be greater than, right? Because it says they want to determine if children are taller in the evening.
Okay, so the lower bound, I have 8.728.
Yep, same.
Okay.
Upper bound is 10.455.
Yep.
Test statistic, I got 22.446.
Yep.
Degrees of freedom are 40.
Yeah.
The p-value is going to be 0 or 0.000.
Right.
Because I got 1.39 to the e to the negative 24.
Yeah, that's what I got. Okay. Yes, we reject the null. Is that C? Because we're less than 0.05. Isn't that what the bound was or whatever? Yeah.
Yeah, so yes, we reject the null. Okay, so C, yeah.
Based on results, is there enough evidence to suggest that children are taller in the morning than in the evening? Oh, wait. No, we would reject the null, right?
Well,
what's the null hypothesis again? Let's see. It's theory, height of children, what values were recorded. Okay.
So I'm thinking for. All right, hold on.
Okay, to determine if the children are taller in the morning than in the evening. Okay, so there's not enough evidence to suggest that, so no. Is there enough evidence to suggest that the children are taller in the morning? No, because we reject the null hypothesis. So A? I don't know, help me out here.
Yeah, you're good. So the null is
That they're taller in the
or that they're taller in the morning than the evening. That's true. So it would be null because we fail to reject the null, right? Because so what I'm thinking is for the type of test, we're actually going to do less than. Or no, it would be great. I don't even know.
Yeah, that's
because
huge.
it says based on the results of this test, is there enough evidence to suggest that the children are taller in the morning than the evening? The answer is yes. Well, I don't know if there's enough evidence, but we would accept the null.
So
I would.
we didn't fail to reject. So it's either B or C.
Well, so the thing that I'm thinking is, I wonder if our type of test is just less than.
If we do less than, yeah, we failed to reject the null.
Right. And the reason that I'm looking at it is because variable 1 minus variable 2, which is the AM minus the PM, is all greater than. So everything, because all the differences are a positive number, it's going to mean that the kids are taller in the morning.
I see what you mean.
So that's the only reason I gave me pause. So that's what I'm thinking less than. We're going to say the type of test is that variable 2 is less than variable 1.
Okay, yeah, I can see that. So then we need to change our p-value then, because that pushes it to 1.
Yeah, so it's 1.0.
And then that means yes, because we failed to reject the null, so D.
Correct. Yep.
All right, let's do this.
Let's see how it goes. $36 out of 43.
I got 35 out of 43. What did I get wrong that you got right?
And our last two are both wrong, so I'm sorry about that one. That was my bad.
That's all right. It's all right. I think we had it right the first time.
Yeah. Let's see. What else did I got? I got number 28 wrong, asking about the confidence interval. So I wonder if there's a different formula we use. Maybe the one you were looking at.
Maybe. I got number 3 wrong.
Number 3. Number 3 I got right. That was the test of two proportions.
Oh, you know, I just must have clicked on the wrong one. Because I have test of one proportions, which is right above it.
Number 8 I got wrong. 9 we got wrong, which is the one that we weren't sure of. And same with number 10. I'll have to go back and look at those. 25 and then 28.
Okay. Well,
right.